It is my great honor to communicate with the provider specialist in Spain. Actually, I had been in Barcelona several times, but today is a most honorable day in my life. And then I will make the short presentation. And then KH told me that I have 40 minutes for presentation file. So it's a little pity because my presentation takes around 2 or 3 hours. So I have to shorten up my presentation file for key points. And then the communication company recording my voice and my face during 40 minutes, a little nervous. I never have been this kind of experience in my life, but I feel I am just like a movie star today. So now we have Korean staffs and the Danish people, and then also the Spanish specialist. It's like an international congress. So I want to introduce our technology and who is cell biotech and what is the benefit of probiotic when you take, if you know the dual coating technology, then you understand our real technology in 40 minutes. I will do my best. Okay. So the agenda is like this. So maybe I will start introduction of myself. I think 25 years ago, I arrived in Denmark, and then I had a PhD in microbiology sector. My professor is Yonsei. He's a very famous scientist in Novo Nordisk in Denmark. And after finishing PhD study, I back to Korea and I built up Cell Biotech Korea. So my background is microbiologist, and we have 20 years experience to produce probiotic and also many education and marketing activities. And then I will introduce the Durac, a patented coating systems, patented in Korea, Japan, Europe, and America, and clinical evidence for coating systems, and also new trend of probiotic research by full genome sequencing. So I want to explain what's the meaning of full genome sequencing in lactose bacteria, and also I will show our factory tour in 7 minutes. Video clips takes 7 minutes, and you can understand how probiotic is produced from strain, fermentation, harvesting, and the coating, and the freeze drying, and then strain cocktail, and finished products, something like that. It takes 7 minutes. So we called it one-stop productions. Okay. Cell Biotech is around 20 years old company, still very young. But in the history of a probiotic industry, the 20 years is not young. So we are the cluster of microbiologists, and we specialize in manufacturing, developing the R&D within the field of probiotics. And then the dual coating technology is classified as first generations. So the probiotic is developing from first generation, second generation, like very strong capsule against the stomach acid. It's very popular in pharmacy. And there's microcapsulation and also dual coating technology. It's a fourth generation coating technology. And what is coating important? Many people ask me, what is different from yogurt? So I say the probiotic has a coating technology, which are different from yogurt. Because probiotic must selling during 1.5 years or maximum 2 years at the room temperature. and we deliver our probiotic to final consumer. And then if received the probiotic, they check, and then another attack from the mouse or stomach acid, and the bile juice attacks, and many spice food like garlic, onion, ginger also kill the bacteria. So there are so many kinds of unpleasant factors from the manufacturing to our faces. So that is a very important point of dual coating technology also. But we think that high bacterial count reaching intestine are most important, because there are so many harmful factors, but bacteria must be in our small and the large intestine, and the colonization, and the minimum 10 or 100 times multiply, and they make effects. So that is a very key point of probiotics. This is the diagram of coating technology. And you can see the first layer, like a brown color, is peptides. So we use the peptides from milk or soya. And this peptide has a very strong biochemical characteristic to aggregate each other. That is a very typical biochemical characteristic of a peptide. So if peptide meets around the pH 4, peptide itself aggregate by themselves. So we use this biochemical characteristic, and also we use second coating layer is like oligosaccharide or polysaccharides. So we call it a kind of biometrics. So three kind of metrics or material are combined together as a one body. That is a concept of coating technology. So we can magnify the particles, and then you can see the 1,500 hold the microscope, and then you can see the many bacteria here. Outside there are so many bacteria, you can see that. And then also this kind of bacteria can be magnified up to 30,000 fold. Then you can see the many bacteria, and here is some coating materials, something like that. So it looks like some, how can I say, very unique characteristics. And then if you think that why bacteria is outside, as I told you before, three kinds of material are combined together as a one body. So outer surface, there are also bacteria. They are killed, of course, 90% in our stomach acid. But how about the inside of these particles? Outside the bacteria, of course, killed. But this aggregation power that protects the bacteria during passage of our stomach acid. The inside, around 95% of bacteria in the particle can be survivable. That is key point. So this is a proven technology for internal and external challenge. It's very good for acid tolerance and bile juice tolerance. And this acceleration test means we have a special test that we keep the bacteria at 40 degrees. In Spain also very high temperature, but this coating material protects bacteria even very high temperature. So our product can be selling in Asia and also South America because of high temperatures. Also very good for cold temperature, of course. But we never recommend by products is keeping in a refrigerators. This is not necessary. Just keep in the room temperature, that is the best stable conditions. So even we increasing 50 degrees, they are very stable. So this is a very key point for transportation or shelf life of probiotic for during 1.5 years. So this is, we call it backnight technology. So if the bacteria is alive, we can see the green color. And if the bacteria is dead, we can see the red colors. So when this bacteria, dual coating technology, meet the gastric acid, like a pH 2, so still they are alive. And even the pH 7, they are very well growing. So this is very typical pictures for dual coating technology backed up by backnight technology. But also bioexposure is also same. So another interesting figure is that so we think what is the negative effect of a gastric acid? If after meal, the pH of our stomach is around the pH 4. But pH 4 is still acidic conditions. If bacteria attacked by gastric acid, they are dying. So why they are dying? And if we supply fresh medium to the bacteria, if they damaged by gastric acid, what is happen? If the bacteria is damaged in gastric acid, and they emit a lot of nutrient in our intestines, so we think they can be survivable. Because if damaged, but there are so many nutrients in our intestine, so they take a nutrient and the survival again. That is a very logical idea. But the microbiological result is negative. Because if damaged by gastric acid, that means they attack cell wall and the cell membranes. So cell wall and the cell membrane are damaged by gastric acid. So if they emit this fresh media, if the bacteria damaged by gastric acid, they never recover. Even they they emit fresh media again. So most important factor to keep the bacteria alive in our GI tract is that bacteria must be protected against the gastric acid as much as possible. Then, if they are also decreasing, but also they emit the fresh media, and they can increasing again. So, if the bacteria damaged by gastric acid, like nude bacteria, just has no protection, just meet gastric acid, and damaged to the cell wall and the cell membrane, they cannot be recovered. So the Urea provide 100 times more bacteria to small intestine. So we have some data, and then we publish the papers. But you can see the number compared to non-coated strains, and you can see the different number among different bacteria. In case of Acidophilus, they are 92% higher than nude bacteria. Of course, we analyze this bacteria in the feces, but in case of Rhamnosus, they have a 220 times higher than nude bacteria. So coating technology is even the same, but each bacteria has a different effect. But the average is around 100 times higher than nude bacteria. And proved by academic papers. But also we have many clinical trials with feces, we call the fecal analysis together. So if we have a human clinical trials, sometimes the data is very different. But this is a scientific backup by fecal analysis. So we have these papers. We have clinical trials for elderly persons. So we have special hospitals. So many the senior people are staying in hospitals, and they have many drugs, many pills for heart or joints or high cholesterol. So they every day they take several pills. So their baseline of microbial flora is much lower than young generations. So if we give probiotic to senior persons, the effect of a probiotic is tremendous because the baseline of microbial flora is very low, elderly person. I think so you have the same hospital systems here. So this, in case of Astrophilus or Rhamnosus, is much higher percentage compared to young generation. So we strongly recommend to probiotic for senior person in hospitals. And individual coating for each of cell biotech strains. That means the coating ratio or degree of coating is different strain by strains. Because Streptococcus is a round ball shape, like round. And the Lactobacillus is just a tube, something like a tube style. And the Bifidobacterium is like a Y styles. So coating must be not same as all bacteria, because we have the coating round type, tubular type, Y type. How we can make a same coating technology and the same degree of coatings is different. I will show what is difference. So in case of Bifidobacteriums, you can just remember this shape, because the Y type is all kind of bacteria inside here. And the surface is looks like here, is in case of Bifidobacteriums. And there is Plantarums. So Plantarum is a very typical Lactobacillus strain, and they are very tubular type. So maybe we have a different shape, and the surface is also fully covered. This is Streptococcus. As you know, the Streptococcus is round type. So we have a very big granules for optimization of Thermophilus. So it looks like this one. And there are so many bacteria or Streptococcus inside of the particle. So even the coating, the basic technology of dual coating is the same, but totally optimized for each strain. So this is a proof of the dual coating technology and the different coating material or ratio and the degree. And also this shows that also these pictures are published now. Without coating technology, the older bacteria are staying here, stomach, and then just like a small intestine, because they are captured in this area only. But if we have a different coating materials, so Streptococcus are staying in stomach and the small intestines, and the Lactobacillus are staying in an area of small intestines, and the Bifidobacterium staying in a large intestine. So location of each bacteria is different compared to nude bacteria. This is also a very strong point of coating technology. So, and then full genome sequencing. I want to show why full genome sequencing is a new hot issue for scientists in the field of probiotics. Because I learned many information on Bifidobacteriums from textbook or university, but they say Bifidobacterium produce vitamin and then other very good nutrients by themselves. But nobody knows Durac strain produce vitamin or not. And it's very difficult to detect vitamin B complex by the HPLC or other analytical tools. So only full genome sequencing can make proof that these bacteria produce vitamin B groups. and also guarantee safety. What is the meaning of safety? The bacteria, lactase bacteria is safety, but why you use full genome sequencing for safety issues? Some bacteria, lactase bacteria, are or can be contaminated by the virus. And also some bacteria contains some fragment of gene from harmful bacteria. So we call it plasmid. So we need very pure DNA sequencing, and we don't want contamination by the virus, but we don't want any plasmid from harmful bacteria, like Enterococcus or some other bacteria. So they produce some small fragment of DNA, and the lactase bacteria take this one. So this is not so good for human originated strain, and not good for the commercial probiotic. So we have to prove our strain are totally clean and not contaminated by virus attack. And also precise strain identification means that sometimes some company has a different identification method. So it's a little bit confusing. But by full genome sequencing, we clearly know what is the name of this bacteria. That is the best way to prove identification of strains. So we analyze 4 strains of bifidobacteriums, and also isolate the origin is infant feces, and we register the gene bank. Okay, so this is very important because the bifidobacterium is very popular in animal, but they are very strong compared to human originated. So we're focusing on the human originated bifidobacteriums, and we want to make a full genome sequencing, and we register in gene bank. Okay. So this is data coming from full genome sequencing. So you can see the BF is we have bifidums, and the adolescent is BREV, and the BG7 is longum. So each strain contains genes to produce vitamin B2. Come in. Come. So the Durac strains have a gene to produce vitamin B complex here. Also, we want to focusing on the HMO. So human milk, we call the mom's milk. It's a very important factor for pediatrics. So bifidobacterium is a major strains for the baby or children. So we want to prove that our strain has a good enzyme systems to digest oligosaccharide, because the trend of modern food is oriented for well-being or organic or zero mileage food, something like that. So in case of mushroom, nut, seaweed are classified as well-being foods. They have a lot of the oligosaccharide. This kind of oligosaccharide or mom's milk oligosaccharide cannot be digested by human-originated enzyme only. So human enzyme cannot digest all kind of oligosaccharide. So we need help of enzyme produced by bifidobacteriums. So there are so many kinds of bifidobacteriums enzyme. So they have some very different profile of enzyme to digest oligosaccharide, and the baby get the very free glucose or mannose or fructose, every kinds of free carbohydrate from the mom's oligosaccharide. That is function of bifidobacteriums. So this full genome sequencing shows that this strain has this kind of digestive enzyme for oligosaccharide. And also, this is a hard issues, the digestion of urea in breast milk. So mom's milk contains many urea, but unfortunately, the baby or the people has no enzyme of urease. So we need help of bacteria to produce urease. So urease digest urea and produce nitrogens, and they can be substituted by amino acid. So this is also good the evidence that the bifidobacteriums or Durac strains produce urease for mom's milk. So this we produce 3 papers now, and then we produce 3 or 5 papers more next year. So this is a new trend of probiotic and the new research tools how bifidobacterium act in our intestines, genetic level. So we have many human clinical trials, but Dr. Hans make a much more professional explanation than I. So we just say we have such kind of items, the IBS or acute diarrhea, and also pylori contaminations, and also acne symptoms. And now we are research on cold and flu. That means increasing the immune system. That we have to check that our baby can overcome flu or cold in the winter times. And then also we study on bone health, and we focusing on the obesity, and also some liver disease we are studying on. So we produce the academic papers with the high score academic papers. We are already published. And also we have an in vitro and the animal model studies, 34 papers already. Because many people think that human studies are most important, but many medical doctors want in vivo test in advance. Animal test result or microbiological result, then medical doctors want clinical trials. So this is necessary to support human clinical trials. And also I want to show one-step production of cell biotech. And then this is a totally different concept from other competitor products. So now you see the factory tour of cell biotech now. And it takes 7 minutes, and I will finish my lectures. Once more. Each process I will explanation by my voice. This is isolation of strains. So we always gathering the diapers from the mom, and then we isolate the bifidobacteriums from the baby's feces. This is a very important process. And then by DNA analysis, we confirmation the name of a strain. There are so many kinds of identification, but we use microscope, biochemical analysis, and also 16S RNA analysis method. These methods are recommended by EFSA now. So the probiotic identification are very much advanced now. So now we have a very good genetic method to identify the strains. This is a biochemical analysis. So which kind of enzyme our bacteria produce, and then can be classified as special strains. This is a preclinical trials, and then we need the safety and the functional of probiotics. And then this is a -40 or -70, the deep refrigerators. We keep the strains, and we use original strain continuously for fermentations. And if we find out the strain, we have to optimizing the fermentation broth. So each strain has their own optimum condition of fermentations. That means we are fermentation specialists, and we have 20 years experience how to ferment our strains. We know growth rate, how fast bacteria are growing, and which kind of nutrient they want, which kind of nutrient they hate, and what temperature and what pH they prefer. That is very good information of each strain. Then we can make a strain cocktail. So the cell harvesting means we collect the bacteria after fermentations. And also we have a coating technology here. And we freeze dry the bacteria. During the freeze drying process, coating technology will be accomplished. So all systems are full automized, and this air is the 10,000 class. That means no bacteria. So if we make the powder after freeze drying, they are very coarse and very hard, so cannot use for commercial the products. So milling process, we can find the very fine powders, and we analyzing again, because sometimes contamination by E. coli or sometimes by the virus contaminations, and then the viable cell counting, all kind of microbiological tests will be done in quality control centers. So every process, the microbiological cross-check is very necessary. They are counting how many bacteria in the 1 grams of powders. We produce around 10 to 11 cells per grams with the coating technologies. And the powders will be fine and more fine, and we dry up again, and then mixing the strain together, and then we make formulations, and then tableting and capsuling, stick and the pouch, all kinds of formats of probiotic, we can produce it. So checking the empty capsules, and then we checking the tablets. Also these GMP facilities, and all systems are automating the systems. And all air are no bacteria, so it's also around 10,000 class here. We produce various products in same factory. And the labeling, and the washing the bottle by air, counting. And this is a leakage test. If the sealing is not good enough, then we can check sealing is perfect or not by high pressure of the water. And also again, we finalizing microbiological test again. So there are several points we have to analyzing the products by microbiological way, and we can produce 100% safety the products. And we keep all the product in safety shelf, and then we exporting all over the world. Thanks very much for your patience. And then this is my end of my lecture. Thank you very much. Thank you.